The top of a 25-foot ladder, leaning against a vertical wall, is slipping down the wall at the rate of 1 foot per second. How fast is the bottom of the ladder slipping along the ground when the bottom of the ladder is 7 feet away from the base of the wall? This is a classical related rates problem, usually introduced in a differential calculus course. The first thing we need to do is to draw a diagram to help us visualize this scenario. We are going to set up a standard horizontal and vertical axis, with positive values increasing to the right and positive values increasing up. You are free to set up your coordinate axes in any frame of reference you want. Just make sure you are consistent with the quantities relative to your coordinate axes. We are going to represent the ladder with a downward sloping line as follows. Next, we are going to assign variables to each side of the right triangle that was formed by the ladder. We're going to assign the variable x to the distance from the wall to the bottom of the ladder, and assign the variable y to the distance from the bottom of the wall to the top of the ladder. We are also going to assign the variable L to the length of the ladder. It is important to assign variables to all the quantities and work with these variables until you are ready to substitute the numerical values. Next, we are going to list all the given quantities. In this case, we are given the value of L, which is equal to 25. We are also given the value of x, which is equal to 7. And we are given a rate of change, or derivative of the vertical contact point between the ladder and vertical wall. We will denote this derivative as dy over dt. Notice that this value would be negative, since the distance between the contact point and the bottom of the wall is decreasing with time, so we will set it equal to -1. Notice that this problem is asking us to determine the rate of change or derivative of the contact point between the ladder and the floor. We will denote this derivative as dx over dt. The next step is to find a way to relate all the variables so that we can take a derivative with respect to time. We will then solve for dx over dt. We can relate the variables x, y, and L by using the Pythagorean theorem. In this case, x squared plus y squared equals L squared. We are going to use this relation to find the value of y when the bottom of the ladder is 7 away from the bottom of the wall. Substituting the values and solving for y, we obtain the following for y. The next step is to take the derivative of the Pythagorean relation with respect to time. Keep in mind that each of the variables might be functions of time, so we need to find the derivative implicitly and apply the chain rule for each variable. Doing that, we obtain the following. From here, it is just a matter of substituting each expression with the given numerical value and solving for dx over dt. Note that dl over dt is the rate of change of the ladder with respect to time. In this case, it will be equal to 0 since the ladder does not change size and maintains its length of 25 as it slips from the wall. Solving for dx over dt, we obtain 24 over 7 feet per second. The bottom of the ladder is moving at this rate when the bottom of the ladder is 7 feet away from the wall, and this is our final answer. Note that we can also use prime notation when solving related rates problems. This way, you do not need to use Leibniz notation throughout the problem. If this video was helpful, please like and share the video, and if you want to be notified when new videos are uploaded, go ahead and strike that subscribe button. Until next time.